Yeah, good afternoon. This is my lithium battery bank. I finally got my 12-volt trip-light AC power inverter moved over here, and then over in the corner there's two big plugs there on my new bus bars. First plug there goes into the inverter, and the other plug and cables go down to my supercapacitor bank there. Just got the super caps down in the corner there. They're rated up to 16.2 volts, and the power inverter is rated up to 16 volts. And so the last month or so I've been working on my interconnect here. So let's see, just take you from here. I come down here from the charge controller. So this is a DC ground fault interrupter, but what this monitors is any imbalance between the negative of the system and your ground connection. That comes down to this middle bus bar here. So this is my main system bus here, positive on the top, all the negatives on the bottom, and then over here I have the trimetric battery shunt that goes to the battery bus. And then I have the shunt over here to my load bus. And then I have room for one more Anderson PowerPole connector there. These are 350 amp rated, and I'm running 1/0 welding cable there. And then on the battery side, because my plans are to have lots of these batteries here, 1/2 kilowatt hour batteries, so for that I need lots of connections. I want these to be as close as possible wiring wise, so I have some 1-inch square aluminum bars there. That's my bus bar, and I've used OxGuard, an anti-oxidant compound on the pins that plug into that bus bar. So I've got a bunch of 175 amp Anderson connectors for each group of batteries. So I come out of that bus bar with a 2-gauge cable, and then I come down here. So I have these little dual fuse modules, 70 amp fuse in each leg, and then out of that I come to one of my battery connection terminals with XT60 connectors, so I can connect maybe 4 or 5 1/2 kilowatt hour batteries in on each side, plugged into one connector, and then I've got 3 more, and I have room for 2 more there. And then actually on the back side of that, in between each one, I think I have 5 more connections. So I could have a lot of batteries, and I've built a bunch of these cables, and they're all exactly the same length. And then the idea with having connectors here is periodically I can pull that cable out, maybe move that group of batteries to the second one, move the second to the third, third to the fourth, fourth over to the first. So I can cycle where the batteries are connected periodically just to even out any voltage differences. But every wire is the same length. These are all the same. They're all the same fuses. So this is 2-gauge, and then I split into a pair of 4-gauge cables, and then each battery has a 10-gauge cable running to each battery. So I'm progressively going into smaller and smaller wire size as I go down. But what I've got here, right there, I don't know what you want to call it, a voltage equalizing tool. I've got a little 21 watt 12 volt light bulb, put a couple of alligator clips on, and so what I've done is clipped across the 200 amp breaker that connects my main system bus here over to my load bus. So what I'm doing is charging up the supercapacitor and the input capacitors in my power inverter right now. So I'm trying to equalize the voltage there. The light bulb isn't lighting up because it was only about 1.5 volts difference between the two. Okay, so I checked the voltages, and we were about 130 millivolts right there. So I've closed my 200 amp breaker, so the power inverter is now hooked up, and we're running at 15 volts. So I'm going to hit the power up button. So let's see what happens here. Okay, No smoke yet, so that's good. Got to plug my power in for my ammeter, and we can take a look at that. I've got the power inverter, so it's pulling 3 amps into the device. That's no load. Yeah, so I've got a bench grinder here. Let's try turning that on. Got an old bench grinder, a Baldor, pulling 108 watts, and we're pulling about 11.6, 11.7 amps. And on the AC side, it's 2.42 amps. So actually, that is pretty promising, because it's usually a 10-to-1 ratio of current. So I've got 2.4 amps AC over here. Yeah, there you can see the AC current, 2.43 amps. And there's the DC current. So normally on a 12-volt system, you would be looking at perhaps 20 amps. So yeah, that's actually pretty nice. Let's see what the charge controller is saying there. 14.7 according to the trimetric, and that's 14.9 there. Yeah, I think what I'll do, I'll turn that off. There we go. So I think what I'll do is I'm going to turn the DC loads off and let the solar panels charge that up slowly today and bring the voltage slowly up towards 16 volts and see what happens. So that may take a couple hours, and we'll just see what happens. See if anything complains about over voltage, things like that. But so far that's looking pretty good. My 12-volt system only has some low power DC loads, a couple amps, so I don't need 600 watts of panels feeding it anymore. So I think what I'll do is move one of my panels from the 12-volt system over to the 16-volt lithium and give it a little more juice there. So yeah, I'll touch base when I get the voltage up a little bit, and we'll see what happens up around 16 volts. If it happens reasonably early today, I'll put it on the end of this video. If not, stay tuned and I'll do an update video when we hit 16 volts and we can take a look at that. When I get to the shed building, this stuff here will be on the top half of the shed, and then the batteries will be in the bottom half of the shed. So that's why these cables are rather long, because they're going to be several feet below this other stuff here. Right now I just put them all right here together because that's the only room I have. Just trying to mock everything up and get an idea how things go together and how much room things take. You know, like this piece here, I've got a shunt, bus bar, another shunt, another bus bar. I do need to add another breaker on the end of the positive bus bar. Right now I don't have a breaker between the positive bus bar and the batteries, so I need to get one of those ordered, and then that way I can shut everything off if I need to. But yeah, I wanted to get it hooked up and see what happens here. If I hit 16 volts, I'll come back and show you this. If not, I'll do a second video, and we can take a look at that later.